Good morning everyone, welcome to the EduSite network. Yesterday we learned the test of significance, under which we discussed in specific the t-test. Today we are going to learn about the chi-square test and f-test in detail. For this discussion we have with us in the studio Dr. Devesh Kishore, a well-known name in the field of mass communication and journalism. We welcome you, sir.
Thank you very much. Today we are going to have mainly discussion on various types of tests, that is f-test, and we are going to discuss also chi-square test. Yesterday we had discussed in last session about t-test, and we discussed also its merits, demerits, how to conduct t-test. The other two important tests are the f-test and chi-square test. Let us understand today where these tests are used, how they are used, what is their purpose, and as a researcher, how do we take decision to use a particular test. Now the f-test, which is also known as analysis of variance, this test has been basically designed to test the variance between the samples drawn from a population. What does it mean? It means from a population, if you have drawn 2, 3, 4, 5 samples, because the population is too big, then you would like to know whether these 4 samples which I have drawn or 5 samples which I have drawn are different, are same, or there is a variance exists between the samples drawn by me. For that f-test has been designed. The main aim of the test is to see whether there is a real difference between the samples. Sometimes it is called treatment, because you are drawing 4 or 5 samples from a population, and therefore those samples could be treatment, or it is only the errors of sampling. So the 5 samples which you have drawn or 6 samples you have drawn, whether the error has crept in because of the methodology of drawing the samples or some other factors. So therefore f-test helps you to analyze the variance but in the samples itself, and to know whether the sample error is affecting it or whether the variance is affecting it. So therefore in the case of f-test, our null hypothesis is, we always try to take a null hypothesis, that our all treatments, all samples are equal. We assume that whatever samples I have drawn from the population, they are equal in characteristics, whatever characteristics could be. That means the difference between them in terms of characteristic is 0. If it is not 0, then they are the different samples, and samples which have different characteristics, and when they have different characteristics, they are not true to the population, and therefore results to be drawn from these samples will give you the wrong interpretations. So therefore analysis of variance becomes very important when you have drawn 4, 5, 6 samples from the population. Let us say, for example, you are studying reading habits, that is of newspaper, in India, and you divided India into the 7 parts or 8 parts, southern India, northern India, eastern India, like that, and you have drawn the samples from there. It means you have 6 or 7 sets of the samples. Now you would like to know whether these samples which have been drawn from the population, they carry the same characteristics or not, or do they vary, or because I have selected the samples from north, east, west, south, so methodology is wrong. So there is a sample error into it. So analysis of variance helps you to know that, and that is why we use analysis of variance for this purpose. Now let us take the example little more in depth and make it more oriented along with the theoretical assumptions. Suppose T is the treatment of the sample. Effect, that means samples which you have drawn, for that we say treatment, and T stands for the treatment. So the null hypothesis would be that all the treatments will be equal. T1 will be equal to T2, T2 will be equal to T3, T3 will be equal to T4, like Tn. You may draw 10 samples, but our hypothesis would be that all the 10 samples drawn from the total population have similar characteristics. They are same. Therefore, you have to check it, how they are same, and then we apply the F test. So, if we find there is a difference, if the hypothesis is disproved, or we might find the result which come within the limit of the chance error, then we accept it. We say, all right, this is error of chance, it has come into it, because we can't find perfect samples. Suppose you have done 10 samples will not be perfect in all the characteristics. There will be little bit variation here and there, but that variation is acceptable to a certain limit. If the variation is too much, we can't accept it, but if it is tolerable, then we can accept it. So therefore, the testing is done by calculating the ratio between the treatment variance and error variance. What does it mean? It means that all the 10 samples, you take their ratio keeping in view the variance itself. We will tell you how to calculate this, and then see that as the probability level, how much the value is coming, and the ratio between two variance is expressed by symbol F. That what we call it analysis of variance or F test. So F test is actually the ratio between the two variances, that is F test. So don't get confused that how from F value has come. This is on the basis of the formula we work out the variance ratio and then we interpret it keeping in mind the value itself. Let us take the example in real sense. I have taken 3 lots, 1, 2, 3. As you will see in the table, there are 3 lots, and then in each lot I have given you the values, that is 7, 8, 8, 9, 8, like that, second also, third also. Now these are the variations in the sample. By just seeing, we can't say anything, because the numbers vary from, in first lot 7 to 9, in second lot 9 to 13, in third lot vary from 4 to 11. Now how do we interpret? Just by seeing is very difficult, impossible also. So therefore we use the F test. Now what we do, we write down all the information in table as shown to you, and then we work out the totals except in case of each lot, and then we also worked out the means. For example, lot number 1, which has 7, 8, 8, 9, 8, total is 40, and 40, how many degrees of freedom or how many numbers are there? 5. So total 40 is divided by 5, and that you get the arithmetic mean. It means the average is 8. Second lot is, if you add up all the numbers 11, 12, 13, 10, 9, the total comes 55, and numbers n are 5. So 55 is divided by 5 and you get 11. In the same way you go to third, and the total is 40, divide by 5, it becomes 8. So you work out the means of all the lots. You know, means are always helpful in comparing them and is also useful for our analysis. Now let us go ahead. The mean which we indicate by the symbol mu. You know, we always give symbols to different words, otherwise every time you will have to write the word itself. It makes the formula easier. So mean here is mu, which is sigma x divided by nk. Okay. Now sigma x in the first, if you go back to the earlier, the total of all the 3 lots, 1, 2, 3, and all the numbers, grand total was 135, if you see in that table. So that 135 divided by number, that is 5, and k, how many replications were there? 3 lots. So 5 into 3, 15. So 135, the grand total 135 is divided by the numbers of the items and the replications, that is 3, 15, and then here mu came 8. So mu is the basic mean of all the 3 in toto has come 9. Now the component of variation due to lots, because there are various lots and there is a component of variation which has come. For that the formula is sum of squares 1 upon n, r1 square, r2 square, r3 squares, and then you will go and see here that first total was 40, then 55, then 40. So what we have done, we have sum of squares to work out. We first took one digit and divided by 5 items or 5 numbers, and then total of each lot, squared it, and then minus the grand total of 135 and grand number, that is 15, and we work it out, and here sum of square became 13, and degree of freedom here 3, because there were 3 lots, or minus 1, as I said that there is no freedom to the last item, therefore degree of freedom is 2, and this 30 has sum of square has been divided by degree of freedom and the value has come 15. Now we come to the component of variation due to treatments, that is the sample. So sum of squares, degree of freedom, we have already worked out, that is degree of freedom n minus 1 is 4, and KVT1, that is sum of squares of 1, 30 came and divided by number of degree, that freedom, that is 4, and the value is 7.5. Then we worked out the component due to error. You see, this is the fourth item. Let me help you to remember. First was mean, to work out mean of all the three. Second was component of variation due to lots, because there are 3 lots were there. Then third one was component of variation due to treatments, that we worked out. And then fourth is component due to error. So there are 4 things which we have worked out. Component due to error, we have another formula. SS due to error is total of sum of squares, lot of sum of squares, and treatment sum of squares, which we have already worked out. So total was 88 minus 30 and become 28. Then we value of total sum of squares 7, 8 plus 4 squares minus 135. These are the formulas which are available. You can work it out. The interesting part would be the value which has come out is 3.5. Now the interpretation starts in F-test. On the first table, top of the table, I have given the formulae, that is how to predict them, how to work out them, and below table I have taken the same example and then worked it out. So let us see how we have done this exercise. Now lots were 3, so degree of freedom would be 3 minus 1, that is 2. Treatments were 5, 5 minus 1 is equal to 4. Error which was worked out was 8, we have written here. The sum of squares which we worked out, 30, 30 and 28, we have written here. Then variance. Variance would be SS divided by degree of freedom, that is 30 divided by 2, 15. Then 30 divided by 4, 7.5, and error 28 divided by 8. So here you will find 3 components have been taken care of. Now we go to the in depth. I think my presentation will just help you to have an awareness, to understand, but you will have to do the exercises on this so that you are able to do it. The observed value of f is compared with the value given in the table for V1 and V1 degrees. Now there is a table which is already available in the market. Printed copies are available in books. So therefore anywhere you can go and find out this table, because this table is useful to know the already the value which has been worked out in advance to help you out, because you will be comparing them with that. So we were working out the details of the f value. So the observed value of f is compared with the value given in the table. That's what point we are saying. V1 and V2 degrees. What is V1, V2 degrees? These are the degrees of freedom which are given in the table. And these labels are generally interested are 0.001, 0.01 and 0.05. If you recall, then in earlier session, while talking about test of significance, we have said that we are interested only basically in 3 at 3 levels. If the other levels, if we want to go to minus this level, there is no point, like 0.0001. Or if we go to bigger, that is 0.1 level, then it's also a variation will be too much. So now here treatment of variance was 7.5, which worked out earlier. Areas of variance was 3.5. You may like to see the earlier slide here, where you can find the lots of 15 and treatment was 7.5. Error was 3.5. So same thing we have written here, and you can see. Therefore, F, analysis of variance value, which we worked out 7.5, there is a treatment of variance and error variance. Treatment of variance divided by error of variance. Then it becomes the V2 value. Here the value has become, when we divided F, then F was 2.143. Now we go to the table. This is the table where you have one side degrees of freedom 1, 2, 3, 4, 5, like that it goes on. On the other side you won't find degrees of freedom of denominator. So we always take help of this table and then work it out. So this table at 5 level of significance, V1 is 4 and V2 is 8, is 3.4. Now when we go on denominator and numerator side, that is, we find 4, 8, the value which is common in the table is 3.84, and this observed value is less than F value at 5% level, so it is not significant. Thus, there is no significant difference between the treatments, the samples. Samples are not different, and then observed value would have been proved significant. Then the interpretation would have been difference between the treatment are real and not to do the error of sampling. So this analysis of variance really helps us in knowing the variance between the number of samples which we have drawn and errors which might have creeped in while drawing the sample, and we are able to know about it. That is what is the interesting part of analysis of variance table. So you can find this table in books, in printed material, and you must keep ready when you are working out F value or analysis of variance, then only this will be helpful. So this is a big question, because t-test is not able to analyze the variance between the samples, and it is meant for a smaller series. F-test is being used when you have various lots and various types of samples, then F-test is used. So this is in a nutshell about the F-test, which we talk about the analysis of variance. In research, basically most of the research workers use F-test, so that they must be very clear that the variance which is coming in the samples, is it significantly different or not. If it is significantly different, then sample has to be not accepted, it has to be rejected, then you have to draw another sample. Now let us come to the next test, which is known as chi-square test. As I was mentioning, t-test and f-test They are helpful in studying the differences between any two distributions, maybe samples, whatever, but they are unable to express all the features of the distributions. That is the problem. T-test and F-test, when you are using, they are helpful to you to know the differences between the samples or distributions, but they are not able to say this distribution, how it has been going in the sample. So that is why for that, to understand the feature of distribution, chi-square test is used by the researcher. Chi-square is not used to find the differences between two distributions. So use chi-square test when you are interested to know the feature of distributions within the sample itself. So chi-square test is represented by symbol which just look like X, but not X, because one leg is bigger. And it is a non-parametric test. In non-parametric test, we do not assume any particular distribution which is applicable, but there is certain value attached to a parameter of the population. It can be made use of comparison between theoretical population and actual data when categories are used. The chi-square test is applicable in large number of problems. We can use in research in large number of population when we are interested to know the features of distribution, which is not known and which will not be known through t-test and f-test. So here chi-square test is used when you are interested to know the features of distribution, how the figures have been distributed in your sample, whatever has been worked out. So the chi-square is being used for that basic purpose. Please remember that when you are using any of these tests, you must know your purpose, you must understand your data, and you must be very clear in what interpretation you are interested in. There is no point in using a test for which it is not meant. Even if you go to a hospital, doctors ask you for different tests, blood test, urine test, cough test, different types of tests. Now one test is not applicable to know or to diagnose the problem related to others, is useless. If you want to check the sugar level, then you will have to go to a blood test, then not perhaps you will go to cough test. So for different things, different types of tests are meant. What I am trying to say is that you as a researcher, you must understand that which test is meant for what purpose, how it will be useful to you, and how you will interpret it. Don't use test for fun's sake, because that has got no meaning. So before using any test, whether it is a t-test or f-test or z-test, chi-square test, you see what you are trying to find out. If you are trying to find out the variation between the samples, 2 or 3 samples, go to for t-test. If you are interested to find out the variance between the samples, then go for F test. If you are interested to find out the frequency distribution in your sample, go for chi-square test. So, for different tests, different purposes are there, and you should be very clear. So, chi-square test is used for basically to express all the features of the distribution. This test is able, let us now summarize as far as the test advantages are concerned. This test is able to help us to know whether particular distribution are in agreement with normal distribution. I hope you know about the normal curve and normal distribution. So, one purpose is that distribution is in agreement with the normal distribution. Number two, two given distributions are in agreement with one another, that you have 2, 1, whether they agree with each other. Number three, two observed frequencies in a particular given ratio. And fourth is two sets of classification are independent of each other. These are all given in statistical terms. So, to understand, you must have the background, otherwise you will not be able to understand all these 4 advantages. But I think even if you don't remember this, at least you remember where chi-square is used, for what purpose it is used, and how it will be used. That will be good enough. So, the chi-square test, that is a test of significance, gives the probability of getting a value of chi-square equal to or greater than the observed one in random sampling. That is what you will get, whatever samples you have drawn. Most of the samples you draw randomly. So, I have taken the expression random sampling. If probability is less than 0.05, which is considered very small, we are justified in suspecting significant divergence between the fact and the theory, and then can declare null hypothesis on the basis of its disapproval. I think you all know about hypothesis. We have discussed number of times what is hypothesis, your assumption. If it is greater than 0.05, we cannot say the hypothesis is proved to be correct. So, this is a interpretation about it. Now, the next question is how to calculate chi-square. I have been telling you to note down or take down from various books, because formula and formulas are given in the almost all the textbooks and also the statistical books. Formula remain the same. You read any book, you go through any written printed material, all over the world, these formulas are acceptable. So, therefore, there is no confusion as far as the formula if you note it down from anywhere, whether it is English book or American book or Indian book or anywhere, formula is same. Only thing you have to understand how this formula, how you can put various figures in the formula and then calculate it and work it out and later interpret it. That is very important. So, see, note down this formula which is given here, that is chi-square is equal to sigma within bracket O minus E whole square upon E. O means observed frequency, E means expected frequency, and that sign is summation. Chi-square can also be expressed keeping in view the variance. That is, chi-square is equal to variance of the sample divided by variance of the population and degrees of freedom. So, what is that? Variance of the sample divided by variance of the population and then degrees of freedom and minus 1. It looks very simple, and it is very simple. Now, I take up the example from journalism. How journalism students can use this? The example is, there are 10 scriptwriters, and all of them have given one news. News is the same, and they have been asked to write the news story. So, contents is same, news is same, and script writers are different. They have been trained in different schools of communication, school of journalism. They have been writing news items, and as you know, as journalists, we accept those news stories which have all the material into it, content, and use less number of words, because space is expensive, is costly. So, therefore, this exercise was done. So, there were 10 script writers, students were invited, and they wrote down that particular news. In this table, I have shown you. A script writer used 38 words, B used 40 words, C used 45 words, D used 53 words. Like that, E has used 47 words. So, different number of words, total words they have used to write the news story. What is our interest? That why this is so variation? The variation is, well, news story is same. Somebody has taken 55 words and somebody has given 38 words. So, there is a variance. This variance is significant or non-significant. So, for that, in first column we write down the name of the script writers. Second column is the number of words, and third column is the difference between mean. Means you work out the mean by adding up all the numbers. In this case, the total is 470, n is 10. Therefore, mean would be 47. So, we minus from the mean 38, 40 minus 47 is minus 9, same thing, minus 7, minus 2, like this, plus 6, plus, and then as I mentioned you earlier, to take care of the minuses, we square it. So, everything has been squared. 9 has been made 81, 7 has 49. So, minus is removed by squaring, and sigma would be x minus x whole square, that is total is 280. Then what do we do? How do we calculate the t-test? This is the preliminary work we have done. So formula you can note down first. 470 was the grand total. If you remember number of words used, second column 470, right? 470 divided by 10. There were 10 script writers. So mean came 47 divided by 10. Then we have put x1 minus x whole square, that is 280. If you remember, go to back to the table. 280 was the x1 minus x square, and this 280 divided by number of degrees of freedom, and then we have worked out the value. Let us say null hypothesis was, to check this hypothesis we need to find out chi-square, and then using this formula. In this formula again we have put the values, and the interesting part would be how it has been calculated, how chi-square has been calculated. That is, whatever the value has come, we have divided by 20 in the seeing the earlier figure. 20 was the variance of population, and this variance of population has divided to the variance of the sample. Remember, variance of the sample and variance of the population. Variance of the sample is whatever sample you have drawn, 5, 10, 15 samples, how they vary, and variance of the population is the population in terms of characteristics, how much variance is there. So the chi-square value has come. Now degrees of freedom is 9, 10 minus 1. According to 5% level of significance, table value of chi-square, I have shown you the table earlier. Now table of the value of the chi-square is 16.92. At 1%, this was 5% level of significance. Let us understand what does it mean. 5% level of significance, table value chi-square is 16.92. When you have gone to the table and 5% level keeping degrees of freedom 9, you find the value is already printed there, 16.92. And if you go to 1% level of significance, the value will be higher naturally, so it is 21.67. Now you have to see whether these values are greater than your values or smaller than your values, because you have calculated 13.9. At 5% it was 16.92, and 1% it is given 21.67. So in both the cases, both the values are greater than the 13.99. What does it mean then? Then it means if your value is, table value is greater, then the hypothesis is acceptable to us. That the variance given distribution can be taken as 20 words at 5% level and 1% of significance. In other words, the sample can be said to have been taken from a population with variance of 20 words. The interpretation would be the script writers, which were 10 in number, which have used number of words for the same news story, are they different from the population? and it has been found they are not different. You cannot reject them on the basis of somebody, if he has used 38, somebody has used 40, then you say he has used 2 more words, reject him. No, you can't do it, because that variation has come from the sample itself. So, chi-square is helpful to the researcher to know exactly how much has been the variation and how much variation he should take care of it, how much he can ignore, how much he should be careful about it, and then make the interpretation. So, chi-square helps him in knowing that, otherwise you can't know. There is no methodology of doing it. I know a number of times students are asked to write a script on a particular news item, and the examiners go through it and they say, no, he has used more number of words, he used less number of words. How do you, as an examiner, you work it out? You have to do a particular research. You will have, if you want to be exact, you have to first find out the variation in the population, then take the variance in the sample, compare them, work out a ratio, and then you will say minus 20 or plus 20 will be acceptable. They will be in first grade. Then after would be in second grade or third grade. Now that exercise has to be done. Just now by 1 mark or 1 words you cannot say is inferior. So therefore that care is to be taken. Now let us come to the conditions for the application of chi-square test. Certain conditions must be satisfied by the researcher before chi-square test is used. He must go through the whole situation. Number 1, number of items in each group should not be less than 10. That is first important thing. Whatever data you are using, it should not be less than 10. If it is grouping, then it should not be less than 10. Then the items in the sample should be independent. Then third is random sampling method must be used for recording the observation. Fourth is the constraint must be linear. And fifth is number of items must be large, at least 50 for better results. I think the most important conditions for chi-square is that number of items in each group should not be less than 10. Number of items must be large, at least 50 for better results. And then the items in the sample should be independent. They should not be dependent on some other factors or characteristics. And fourth important thing is random sampling technique must be used. You should not use a specific purposive sampling technique because they will not give you the correct results. So therefore random sampling has to be used. Now these are the conditions to be satisfied before you use chi-square test. I have seen some people have used on less number of items, 8 items in the group. That is not correct. You must satisfy the conditions. If conditions are not satisfied, you may not get the correct results. That is what is very important. So please note down that these are the 5 important conditions which must be met by your data before you go for using the chi-square test. Otherwise, you are not going to get the correct results. Then if you go and think about these F test and chi-square test both, as a researcher, when these two tests have to be used, or even if you take T test, all these three tests which we have discussed, conditions must be set that these are the conditions which have to be taken care of while using the sets or while using the data. Otherwise, you will not be able to do it. As I explained you, that F test is analysis of variance test. Analysis of variance test. And T test was to see the variance in the samples. Please take care of all these three tests and then use it for your research purposes. As I gave you the crude example of a human being who is having temperature, and if he goes to doctor will not put him all the tests. He will say, have a blood test first, because he want to diagnose first thing whether he has malaria, whether he has some other type of things involved in him. Blood test is enough. But nowadays you will also find doctors write so many tests which are irrelevant, which will not give him anything. Of course, you can go for various types of tests. There are about 2000 types of tests for human being. But what is the result? You are simply checking the causal organism for fever. So for that the blood test is enough. Not all types of test which is required. In the same way, in statistics, analysis of your data, you don't require all the tests. Some researchers I find, they are very much interested in using the tests just for maybe a fashion. There is no fashion in it. You must use that test which is meant for that purpose. Otherwise, you are not going to get the correct analysis, and that care has to be taken. So my submission would be that as a researcher, use statistics very carefully. Before using it, read every test's merits, demerits, find out in which conditions they be to be used, for what purpose they are going to be used, and what would be type of interpretation in which you are interested in. So unless you are very clear about it, you will not be able to do it. There are number of other tests which we might discuss sometime when we get time. But as initially a research worker, if he knows these 4 tests, that's enough. If you are going in depth, more analytical way, then you can go to more. There are a number of other tests which we do not recommend to the research workers who are interested in social issues or social problems, because if you are a student of genetics or a student of botany or physical sciences, you can go more in depth and make further analysis. But in social phenomena, we do not go in that much of details. Therefore, we limit to only basically these important tests and we use it for our purposes. So, therefore, as a student of journalism and communication, you will be required to use most of the time the t-test, f-test and chi-square test. In social phenomena, we are using these three different types of tests that will be useful to you. Please also remember, don't get confused. All these three types of tests, their formula are available in all the statistical books. They have been described. There is no change as far as the formula is concerned, that one book gives you another formula, second book gives you another formula. No, they are same. Only thing is that you must understand well. Take the help of the experienced researcher who can explain you in a better way and then start using it. Otherwise, you will be using a wrong test and deriving the wrong interpretation, which will give you the wrong results. So, using a particular test for a particular purpose will be the best to get the proper results. I think this must be taken into consideration. There are very good books available. I can suggest you there are some old books, there are new books. One book is by Good and Hutt, Methods of Social Research, which is an old book, but is available in most of the libraries, I find. Then there is another book by Indian author Dr. Bajpayee, S.R. Bajpayee, Methods of Research. Then there is a book in Hindi language on research available in the market, written by Dr. Manoj Dayal. Now, the latest book of mine has also come, which has been published by Makhanlal Chaturvedi, University of Journalism and Communication, Bhopal. The title of the book is A Handbook to Communication Research, where all these details you will find which are given. There are books in other fields also, like in management, psychology, sociology. Now, these books in these areas will give you an idea how the same formula is used for analyzing the sociological issues, anthropological issues, management issues. Since you are a student of communication and journalism, use the book which has been written from this point of view. So, it will give you a clear idea how to use these tests in communication research or in journalism research. Otherwise, you will have to copy it and understand how it is to be used in your discipline. So, you may take it from anthropology, or you may take it in sociology, or from management, but these books will be, of course, giving the examples of the, suppose you take management books, then they will give an example of the management. But if you are taking a sociology book, sociological. But if you take communication and journalism book, then you will get the examples of that. That will suit you.
Right. Thank you so much, sir. So, friends, today we looked at the chi-square test and the F test, and yesterday we had looked at the T test. So, as you have seen in the lecture, they have been discussed clearly with vivid examples, and as sir suggested, one must practice for a greater understanding, and one could easily apply them to research when conducting research. And sir has mentioned a number of books, so they would be very useful sources for consultation and also looking at the formulas. So I would like to suggest to you all that if you missed out on any information, you could tune into YouTube and search for this lecture, and for the rest, have a nice day. Thank you for watching. Thank you, sir.